So let's read about the Mohr stress diagram. So this diagram is useful in simplifying the already existing equations. We have two equations. First equation is tau is equal to 1 by 2 sigma 1 minus sigma 3 sin beta cos beta, and second is sigma is equal to 1 by 2 sigma 1 plus sigma 3 minus 1 by 2 sigma 1 minus sigma 3 sin beta. So to get these equations, we use the Mohr circle diagram. So the Mohr circle diagram is a two-axis circle. So suppose this is sigma 3 and this is sigma 1, this is 0, so we know that this is center point sigma 1 plus sigma 3 by 2. Considering this to be a center, we will draw a circle. Okay, so this is the circle. In that circle, suppose there is a point, so these axes represent, this represents sigma, this represents tau. So let's suppose there is a point P where we need to find out the tau and sigma for that. So we draw a line joining this circle and we draw a vertical perpendicular. Suppose this angle is beta and this is 2 alpha angle we consider. So we know that for this circle this is the radius. Now what is this radius? The radius is same as this thing. So we know that point O is sigma 1 plus sigma 3 by 2, and this point A, this is B. So this is the radius. So what is the radius? R. R is equal to O minus A, that is equal to sigma 1 plus sigma 3 by 2 minus sigma 3, so that is equal to sigma 1 minus sigma 3 by 2. So we know that the radius is R. So what is going to be this component? If a line makes angle theta with another line, so there we'll get the cos component and the perpendicular of it will be sine component. So this portion, this much portion will be the sine component. So we know that this point will indicate the tau value. The tau value will be R cos beta, means R is equal to sigma 1 minus sigma 3 by 2 cos beta. Again, let's talk about the this value. So this is how much is going to be the sigma for, this is how much is going to be the sigma for this point P. What is this value? Sigma 1 plus sigma O minus this O minus this this point, this value. So O, suppose let's consider to be Q. So what is going to be the sigma value? That is equal to O minus OQ. So that is equal to sigma 1 plus sigma 3 by 2 minus what is OQ? OQ will be the vertical component of R, that is equal to R sin theta. So that is equal to sigma 1 plus sigma 3 by 2 minus sigma 1 minus sigma 3 by 2 sin beta. So this is the value. Now what is the use of this Mohr circle? So for different value of sigma and theta, we get the different taus. So suppose if the values are less, we'll get lesser values of torque. Then as the both values increases, as sigma 1 also increases, sigma 3 also increases, then it would result in sigma 1 plus sigma 3 by 2 also increase. So the center will keep on moving these points. Once it will reach this point, this point, this point, this point. So the circles will keep on increasing. So they keep on getting bigger. So if we, and these are the points of failures, or these are the points where we are going to find out the stresses. So if we draw a tangent to these circles, it will meet somewhere here. So suppose this is C and this is tau, this is sigma, So we know that any equation of any line is equal to y equal to mx plus c. So this, what is y here? Y is torque here, y-axis. So torque is equal to m. M is nothing but tan theta. Suppose let's write tan theta is equal to mu. Mu, what is x-axis? X plus c. So this is what the equation of the Mohr failure and envelope. So this is whole diagram. This is called the Mohr failure envelope. So the curve joining points of the failure for different stress state is called the Mohr failure envelope. In the envelope reflect the following things. First, the value of the shear stress. The value of the shear stress required to produce the failure increases as the hydrostatic pressure P. So hydrostatic pressure P is nothing but the sigma 1 plus sigma 3 by 2. As this increases, tau also increases. The value of tau required to produce failure under tension is much smaller than that required for compression. So the why it is said, because this is the positive value of sigma, this is the negative value of sigma, negative axis. The positive value of sigma means compression and negative value of sigma means tension. So, and when the circle is in negative region, so sigma 1 plus sigma 2 by 2 is 0 and even getting negative also. So for that we require very less torque. So in tension tau is less compared to compression. And the tensile shear features Mohr envelope in the tension field makes smaller angle with sigma 1. So this is what the Mohr failure criteria is.